Jai Hind everyone. I am Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, we will learn about the queue in data structure. This is the content that I will discuss in this lecture. At first, we will see the introduction of queue. What is queue in data structure? After that, we will see some applications of queue, and after that, implementation of queue using array. How we can implement queue using array? There are two techniques of implementing the queue in data structure. First one is using array and second one is using linked list. So, particularly in this video lecture, we will discuss about how can we implement the queue using array. And during the implementation, we will see insertion and deletion in queue. What are the algorithms or what are the basic steps that are used to perform insertion and deletion operation in a queue. After that, we will discuss about the circular queue. Okay, so let's start with the introduction of queue. Actually, queue is a data structure which is used to store the data element. It is a linear data structure, and this follow the basically first in first out principle. It means the element which is inserted first in the queue, that will be removed first from the queue. So, queue is a non-primitive linear data structure that permit insertion of element at one end and deletion of element at another end. Actually, basically, in case of stack, there is only one end, that is known as the top of the stack, and insertion can be performed at the top of the stack and deletion can be performed at the top of the stack, because stack is a LIFO data structure, last in first out data structure. But in case of queue, it is a first in first out data structure, and it has two ends. One end is known as the front and another end is known as the rear. At front, the element will be deleted, and at rear, the element will be inserted. So, whenever we want to insert an element in a queue, then that particular element will be inserted at the rear end. And whenever we have to remove an element from queue, that element will be removed from the front end. Okay. So, the first element that get added into queue is the first one removed from the queue. That is why the queue is known as the first in first out data structure. Okay, so queue is a linear data structure which follow the first in first out principle. It means the element which is inserted at first, that will be removed first from the queue, and in order to perform the insertion and deletion in queue, there are two ends. One end is known as the front. At the front, element will be removed, and at the rear, element will be inserted. Okay. So, this is the basic diagram representation of queue using array. This is a array which can store 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, this queue is full. This is a queue that can consist maximum 8 elements. So, this is the front. It means the first element that will be removed from the queue, that will be 10. And since after here, after there is no space for inserting the new element, so rear represent the max size minus 1. So, queue is full. But suppose this space is empty. Suppose this space is empty and this is the value of rear. So, in order to insert an element at this place, at first we have to increase the value of rear, and at a new value of rear, the element will be inserted. Okay, so here 10 is the element, first element that will be to be deleted from the queue, and 80 is the last element. Okay. So, applications of queue. Basically, queue data structure is widely used in some real world applications. Various applications that are where the queue is implemented are, first one is the job scheduling. Job scheduling, actually whenever we work on a computer system, then in order to execute the user process, this is the task of the operating system to provide different type of resources to the user process. Okay, so whenever in multi-programming environment, whenever multiple processes are submitted to the operating system, then those processes submit inside a queue. For example, at a particular instant of time, suppose there are 3 processes, P1, P2, P3, or 4 processes, P1, P2, P3, P4. Okay. So, these are the user process to which a user want to execute. So, whenever the process are submitted to the operating system, then those processes are submitted in a queue, and this queue is known as the ready queue. Okay. Now, depend on the CPU scheduling algorithm, operating system allocate the allocation of the CPU for the process who are waiting in the ready queue. If we are using the FCFS CPU scheduling, then the process which come first in the ready queue, that will get the allocation of CPU first. Okay, suppose first P1 is submitted in the system, then CPU at first will execute the process P1. When process P1 will complete, after that CPU allocation will be given to the process P2, and after completing the P2, the allocation of CPU will given to the process P3. So if we use the FCFS CPU scheduling algorithm, so in the order in which the process submitted to the system, in same order the CPU allocation will be given. So what I am trying to say? I am trying to say that whenever the user process submitted to the operating system, they submit in a ready queue. For storing those process in the operating system, a ready queue is used, and from this ready queue the process will be removed and allocated to the CPU. Okay, if at first process P1 is inserted, then it will remove first, allocation of CPU will given to process first. Okay, so this is the this process is known as the job scheduling. It means allocation of the CPU to the process who are waiting in the ready queue. This is the basic application for job scheduling and in multi-programming environment. Actually, multi-programming means what? Whenever more than one process are there to execute, are waiting for the execution, yeah, or more than one process are available in the main memory at a particular instant of time, then such type of environment is known as the multi-programming environment. So in order, in case of multi-programming environment, in order to execute those processes, at first whenever the process submitted to the operating system, they are stored in a queue, and that queue is known as the ready queue. So in order to submission of the process arrival to the operating system, a queue is maintained. Next application is BFS. BFS is known as the breadth first search technique. Basically, this technique is used for the graph traversal algorithm for the graph data structure, and BFS technique use the queue. If you want to implement a program for the BFS technique, then in order to implement that BFS technique, we have to use a queue. We have to implement the queue. Next application is computer network system queue application in router and mail queue. Actually, in the network, in router, a queue is maintained to store the data packet arrival from the networks and send those data packet to the intra network. Okay. So these are some applications of the queue. Apart from these, there are some more applications of the queue, like in traffic system. In traffic system, queue is also maintained for signaling the light. So at first we will see the insertion in queue. How can insertion be performed in a queue? What are the steps that are used to insert an element in a queue? Here we are talking about the array implementation of the queue. So whenever we implement the queue using array, so at first we have to define the maximum size of a queue. Suppose we have a queue that can store maximum 5 elements. So index will be 0, 1, 2, 3 and 4. Suppose this is a queue and this is the max size, and max size of queue is suppose 5. Okay. So at first we have declared a queue with max size and define the max size, and suppose num is a variable which represent the value to be inserted inside the queue, and front is another variable which represent the end of the queue from which the element will be deleted, and rear is another variable that is corresponding to the end at which the insertion will be performed. Okay. So this is the declaration part. It means we are going to insert an element in queue. So at first we have initialized some variable or some data structures. For example, we have initialized integer type array queue that can contain maximum size of element like 5. We declare a integer type variable num which represents the value to be inserted in the queue, and integer type variable front which represent the end of the queue from which the element will be deleted, and rear represent the end at which the insertion will be performed. Initially when queue is empty, this is a queue that can contain maximum 5 elements. So initially when this is empty, then front is equal to -1 and rear is equal to -1. This is the condition for the empty queue. So initially whenever we are going to create a queue, then the front and rear will be initialized with -1. Okay. So step 1, if rear is equal to max size -1, then queue overflow and return. It means what? We are going to insert an element in a queue. Okay. So at first we will check whether queue is full or not. It means whether there is any space available in order to insert the element. If the space is not available, so we cannot insert the element in queue. So suppose first element is inserted here, 11, 12, 13, 14, 15. So when rear reach to, when we insert the last element, then value of rear will reach to 4, and 4 is the max size minus 1. So if rear is equal to 4, then we will say that we will print a message that rear queue is full and further insertion is not possible. Else, otherwise, if queue is not full, it means we have to insert, space are available, and we have to insert the element. Okay. So whenever we are going to insert the first element in queue, at that situation, this condition will be used. If front is equal, initially what happen, when queue is empty, then front is equal to -1 and rear is equal to -1. Now we are going to insert the first element in queue. So we have to set the front is equal to 0. Okay. And rear is equal, front is equal to 0 and rear is also is equal to 0 for the first element. For the first element. So this is 0, front also represent to this and rear also represent to this, and at queue of rear we will insert the num. Suppose we have inserted the 11. Okay. Now after inserting the first element, to insert the second element, we simply use this step, rear is equal to rear plus 1. At first we have to increase the value of rear. So here rear is equal to 0. So now rear is equal to 0 plus 1. It means 1. So now queue of rear, the new value will be stored at the index represented by the rear. Okay. So again 12 is stored at 1, queue of 1. Now in order to now the rear is this. Okay. Now we are going to store the insert the third element. Then what we will do, again increase the value of, using this step, increase the value of rear by 1, rear plus 1. It means 1 plus 1, that is 2, and on the 2 index inside the queue we will insert the third element. Okay. Now queue represent to rear represent to 2, so third element is inserted here. Okay. After this, when we are going to insert the fourth element, then again rear is equal to rear plus 1, 3, 2, rear is equal to 2 here, 2 plus 1, that is equal to 3. So queue of 3, at queue of 3 the new element will be inserted, suppose 14. Okay. So rear become 3 and we insert the 14 at this. Again next here rear is equal to rear plus 1, so 3 plus 1 is equal to 4. At queue of 4, the new element will be inserted 15. This will be the rear. Now, after this, since rear is equal to 4, so if we try to insert the new element, then at first we will increase the value of rear. Rear is equal to rear plus 1, 5, or you can say that here rear represent the max size minus 1. So now queue is overflow or queue is full, insertion is not possible. So this is the algorithm that we use, that we follow to insert an element inside the queue when we are going to implement the queue using array. Okay. Next, let us see the deletion. What are the steps that we are used for deleting the element inside the queue? Suppose initially queue is in order to delete the element from queue, at first we check whether queue is empty or not, because if queue is empty, it means there is no element stored inside the queue. So what we will delete? Okay. So in order to delete, at first we check whether queue is empty or not. And what is the condition for checking the emptiness of the queue is, if front is equal to -1, then we will simply print that queue is underflow. Underflow, here underflow word represent to empty. In that case queue is empty. Okay. Otherwise, suppose queue is not empty and there are some values stored inside the queue like this, 13, 0, 1, 2, 3 and 4, 14 and 15. So this is the front and this is the rear. Now we are going to remove the first element of the queue. So this is the num. Here num variable represent the element to be deleted. Okay. So queue of front, that value will be deleted which is present at the front of the queue. So initially front represent to 0. So what value will be assigned to num? Queue of 0, it means 11. So what happen? 11 will be the first element to be deleted. Okay, so num value of front will be assigned to the num. We will print the simple value of the deleted element. Okay, and suppose we have deleted this. Now after deleting, the next element to be deleted will be 12. So after deleting a specific element, we have to increase the value of front by 1. Okay, so we will do front is equal to front plus 1. Initially front is equal to 0. 0 plus 1, that means 1. It means next element will be deleted from the 1 index. Suppose you have deleted 8. Again, after deleting 12, we will again perform front is equal to front plus 1, that is 2. It means front represent to index. Next element will be deleted from this equation. Okay, so whenever we have deleted a specific element from the queue, then after deleting the element, we have to increase the value of the front. Okay, and that new value of the front will represent the location inside the queue or index inside the queue from where we have to delete the next element. Next condition, if front is equal to rear, then front is equal to rear is equal to minus 1. This condition is basically used whenever we are going to delete or remove the last element of queue. Okay, suppose you have deleted this, and whenever you are going to delete this element, then in this step, what happen? Front will be represent to this. Okay, and after deleting this, whenever you will perform this step, front is equal to front plus 1. So front is equal to 4 plus 1, that will 5. It means now front is greater than rear, because rear is what? Rear is 4 and front is 5. Again, rear is 4 and front is 5. Again, after deleting the last element, when we will increase the value of front, then front value will be 5 here in this case, and the rear is 4. So front is greater than rear. It means queue is again empty. So whenever all the elements are removed inside the queue, then queue will become empty. So in order to represent an empty queue, we will set the value of front and rear as minus 1. Okay, so these steps are followed in order to perform the deletion operation in queue. Next one is this is just an example. This is a empty queue. Here initially front is equal to minus 1, rear is equal to minus 1. Okay, next we are going to insert the first element inside the queue. So we have to set front is equal to 0, rear is equal to 0. We have stored the value 20. Next, again we are performing the insertion. So we will increase the value of rear by 1. So rear is equal to rear plus 1. Here rear is equal to 0. So rear is equal to 0 plus 1. Next element will be inserted at this position. Again the next element will be inserted at 1 plus r is equal to rear plus 1, 1 plus 1, 2. Okay, now see the deletion. Suppose we have to delete this. This is the element in queue is deleted from the front, and initially front is at 0. So 20 will be the first element to be deleted. So first element is deleted. Next we will increase the value of front. Front is equal to front plus 1. So next element will be deleted will be 30, and at this position 40 will be deleted. So this is the pictorial representation of insertion and deletion operation inside the queue using array. Okay, next let us see about the circular queue. What is circular queue? Actually in case of normal queue or basic queue, there is some limitation. What happens? Suppose this is my queue 11, 12, 13, 14 and 15. These are some element. This is the index 0, 1, 2, 3 and 4. This is front and this is rear. Okay, so suppose I have deleted 11, then this space become empty. Now I have also deleted 12. Now this space become empty. So after deleting the element is stored at the index, so when we will delete 0 and element is stored at 1, then after that front will be this. So this space is empty and this space is also empty. So if we are trying to insert a new element, suppose I am going to insert the 16 element, then space is available, 2 space is available, 1 0 index is available and 1 index is available. What? I cannot insert the 16 here, because insertion is performed only at the rear, and rear represent to rear represents to max size -1, 4. So in this situation I have 2 space available in the queue, but we cannot insert the new element. So this space is useless for me. So in order to solve this problem, the circular queue is basically used. In case of circular queue, what happens? The last element is connected to the first element and it form a circle. And in case of circular queue, we perform the circular increment of the rear end. So after n, we can start the insertion from the beginning. This is the concept of the circular queue. Okay. So this is the pictorial representation of the circular queue. This is the 0 index, this is 1 index, 2 index, 3 index, 4 index. At first element is inside. Initially when the queue is empty, then front is equal to -1, rear is equal to -1. We will see in the next slide. So let's see the insertion algorithm in the circular queue. So this is my queue array, and this is the max size, which represent the how many number of element the queue can store. Okay, and front represent the end from which the deletion will be performed. Rear represent the end at which the insertion will be performed. So if front is equal to rear plus 1, here rear is equal to rear plus 1 modulus max size. Max size. This formula is used for the circular increment. In case of normal queue, we will use rear is equal to rear plus 1. This is the normal increment. But in case of circular queue, in order to perform the insertion from the beginning after end, okay, so we have to use this formula, and this formula basically represent the circular increment. Okay, so what we will do, suppose this is a empty queue. Okay, initially when the queue is empty, then front is -1 and rear is -1. Front is -1 and rear is -1, and we are going to, so at first we are going to insert the first element inside the queue. Then we have to set the front is equal to 0 and rear is equal to 0 in order to insert the first element. Okay, so what we will do, we can simply perform this operation. Rear is equal to rear plus 1 modulus max size. Okay, or initially we will set after when we are going to insert the first element in queue, then we will set front is equal to 0 and rear is equal to 0. Okay, so we have inserted first element. Now in order to insert the next element, so this is front and this is rear. In order to insert the next element, we will use rear is equal to rear plus 1 modulus max size. Okay, so rear is equal to here 0 and 0 plus 1 modulus 5. So what will happen? 1. So next value of rear will be 1. It means the next element will be inserted here. Again, when we will perform this formula, we will increase the rear, perform the circular increment of the rear using this formula. Then I will obtain rear is equal to 2. So next element will be inserted here. Again, next element will be inserted here. So what happen? To insert an element, we use this particular formula. Rear is increased by rear plus 1 modulus max size, and this represents the circular implement. So what happen? In order to insert an element queue, at first we will check whether there is a space in queue or not, whether queue is overflow or not. So front is equal to rear plus 1 modulus max size. This condition is basically used to check whether the circular queue is overflow or not. If this condition is satisfied, we will see it in the diagram. If this condition is satisfied, then we will say that queue is flow, or queue is full, or queue is overflow. Otherwise, if queue is not full, it means there are some space to insert the new element. So at first we will read the value of num variable. Num represent the value to be inserted or element to be inserted in the queue. So we will enter the value of num, and if front is equal to -1, then front is equal to 0 and rear is equal to 0. It means this step is basically used whenever we are going to insert the first element inside the queue. Okay, initially the queue is empty. Initially the queue was empty. So whenever we are going this element, first element inside the queue, we have to set front is equal to 0 and rear is equal to 0. Okay, else it means if there are some element like here 11 is inserted, then we will use this formula to calculate the new value of rear. So 1, 2, 3, and after 3 again we perform 3. Rear is equal to 3 plus 1 modulus max size. It means 4 plus 4 modulus 5, then 4. So new value of front rear will be 4 and new element will be inserted at here. Now next Now when we increase the value of rear is equal to what? 4 plus 1 modulus max size. So here how many element it can store? It can store 1, 2, 3, 4, 5, 6. 6 element it can store. Okay, so modulus 6. So 5 modulus 6, it means 5. Next element can be inserted here. Okay, actually here we are taking the maximum size at 6. So now the queue is full. So when if we try to insert the new element, what happen in this situation? After inserting this element, when we perform rear is equal to rear plus 1 modulus max size, in this case 5 plus 1 modulus 6. So it will represent to 0. Okay, so front is equal to 0 and rear is equal to 0. So that is why if front is equal to rear, then set front, in case of insertion here, if front is equal to rear plus 1 modulus max size. Okay, so 5 plus 1 modulus 6, it means 0. So this situation represent the queue is overflow. Okay, 5 plus 1 modulus 6 is equal to 0 and front is 0. So front is equal to this. So it represents the queue is overflow. That is why we have used this condition to check whether queue is overflow or not. Next, insert deletion operation in queue. So in order to delete an element in circular queue, we have to use this step. So whenever we are going to delete an element in queue, at first we will check whether queue is empty or not. Because if queue is empty, it means there is no element to delete from the queue. So in order to check the emptiness of the queue, we will use this condition. If front is equal to -1, it means queue is underflow or empty. Okay, so deletion is not possible. Otherwise, what happen? Num, here num variable represent the value of the element to be deleted, and in case of queue the element is always deleted from the front. So the value will be deleted from the front and it will assign to the num variable, and we will simply print deleted element from circular queue is num. Okay, otherwise this is the basic step. After that, if front is equal to rear, then set front is equal to rear is equal to -1. It means whenever we will delete the last element, okay, after deleting the last element, if queue become empty, then we will reach at this situation when the value and front and rear will equal. So after deleting the last element, queue is going to become empty. So for empty of the queue, we have to set the value of front and rear as -1, because when the front and rear represent to the -1, that is the condition for the emptiness. So this particular step is basically used after deleting the last element. After deleting the last element of queue, suppose in queue there are 5 elements. Okay, so, we have deleted this, we have deleted this, we have deleted this, and we have deleted this. So after deleting this, suppose here is an element and we have deleted this, then all the queue will become empty, and in order to represent the empty queue, we have to set the value of front and rear as -1. So this is step is basically used whenever we are going to delete the last element. So after deleting the last element, queue become empty, and this condition is set. Else what happen? Front is equal to front plus 1 or modulus max size. For example, here, okay, this is the first element. First element was there. Now, suppose we have deleted this element, then we will use this condition to delete the next element. Front is equal to front plus 1 modulus max size. Okay, so 0 plus 1 modulus max size is here 1, 2, 3, 4, 5, 6, 6. So 1. So next value of front will be 1. When we delete this element, then next value of front will be this. Okay, so whenever we perform deletion in normal cases, then we will simply use this condition. Front is equal to front plus 1 modulus max size. So in this case, we will perform the insertion and deletion in circular queue. Okay, thank you.